In this video, we'll go over some general graphing principles, starting with a review and then getting into some new material. So the grid that you see here is called a coordinate plane. The XY, in parentheses like that, is called an ordered pair, and it marks a location in the coordinate plane. And the coordinate 0, 0 is called the origin. So that's review. Plotting the following points, remembering that x comes first and then y, we have the point 3, 1, 2, 3, 4. So that's point A. Point B is negative 3, 1, which is right here, except I just put it at negative 2. Sorry. Negative 6, 0 is the point right here. That's C. And then 0, 5 means 0. Don't go left or right. And this is point D right there. So just make sure that you can plot points. This is old stuff. You should be able to do this. Now, this next formula, next two formulas actually, are some things that you haven't done before probably. The first one is the distance formula for finding the distance between 2 points. For example, point A and B there. So it's a rather complicated formula. It's the square root of, and then you can see everything that's underneath. So I just rather demo it and have you see how it works. So it says find the distance that we call D between the points negative 4, 5, and 3, 2. So we're going to label this x1, y1, x2, y2, just like you do when you find slope. And now you just plug it in differently. So the distance formula says it's x2 minus x1, so 3 minus a negative 4, so 3 minus negative 4, and then that's squared, and we add to that y2 minus y1, 2 minus 5 squared. So that would be 7 squared, or 49. This is negative 3 squared, which is 9. You can't take the square root of 49 separately because of that plus sign. So that gives you square root of 58 is the distance. Now this is the exact distance. If you wanted an estimate, you would put square root of 58 into your calculator, and it's approximately 7.62. This, however, is just an approximation. It's been rounded off. The exact includes the square root. So it's just a matter of plugging in to this formula. That's all it is. Same thing with the midpoint. If I want to find the midpoint between two lines of or 2 points joined by a line segment, for example, the point negative 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 5. So this point and the point 3, 1. If I want to know not the distance between them, but what is the point that's right in the middle, that is called the midpoint. And all it is an average. The midpoint is an average of the x's and an average of the y's. So if these are my 2 points, point 1 is negative 5, 5, and point 2 is 3, 0. To find the midpoint, first off, it is a point. The midpoint is a point on the line segment that connects those 2 original points. What I do is I add my 2 x's, so negative 5 plus 3, and just like you do with any average, if I'm adding 2 things, I divide by 2. And then I add my 2 y's, so 5 plus 1, and I divide by 2. That gives me the point negative 2 over 2, 6 over 2, or I could say that the midpoint of that line is the point negative 1, 3. Now let's see if that makes sense. Negative 1, 1, 2, 3. Yes, it does. That's a point on my line, and I can see that it makes sense. So midpoint is an average of your x's and an average of your y's for your endpoints. Whoops, I skipped a page. So let's go to the page that I skipped and talk about points on a graph. If the point AB is a point on the graph of an equation, then a relationship between x and y, which means that it's a point on the graph of the equation, then when x equals a and y equals b, the equation is satisfied. So let's look and see if these points are on the graph of the equation 2x minus y equals 6. So we want to know if the point 2, 3 is a solution to that if it's a point on the graph or if it satisfies the equation. That all means the same thing. So all we're going to do is just plug in. So you are going to plug in the 2 for the x and the 3 for the y. So it would be 2, take out the x, put in the 2, minus y would be minus 3. And we want to know, does that equal 6? Does 4 minus 3 equal 6? It does not, so no, this is not on the graph. Let's check this one. 2 times 2 minus a negative 2, be careful with symbols and signs. So 4 plus 2, does that equal 6? Yes, it does. So this is a point on this graph and does satisfy that equation. Example 2. If 6 comma b is a point on the graph of y squared equals x plus 3, what is the value of b? Well, we know this is the x and this is the y. So if I take out the y and I put in what's in its place, I would have b squared equals x is 6 plus 3, or b squared equals 9. B squared equals 9. If I now take the square root of both sides, I get b equals plus or minus 3, meaning the point 6, 3 satisfies the equation, and the point 6, negative 3 also satisfies the equation. So you could say it either way. To graph an equation, I'm reading right here, either get the linear equation in slope-intercept form, which is this, and use the slope and y-intercept, or create an xy table with at least 2 points. And sometimes I do it one way and sometimes I do it the other. It just sort of depends on what you're given. So if I was asked to graph this equation, I wouldn't do an xy table. I can see that this is going to be easy to graph because it's in y equals mx plus b form, so I know that my intercept is the point 0, 1, 2, 3, 4, 5. So there is my intercept, and I know that the slope is 2 over 1. And 2 over 1, when that is your slope, it means, since they're both positive, up to right 1. So from this point I can go up to right 1. I have a second point. I can connect them and I can graph them. Now if you prefer, you could have done an xy table. Since the y has a 1 in front of it, it's easier to pick points. For x, I would have picked 0 and 1. If I pick 0, you would get the point 0, 5, which I already showed. If I picked 1, you would get the point 1, 7, and that's the point right here, and it turns out exactly the same. On this next one, because it's not a linear equation, I cannot get it in the form y equals mx plus b. So I'm going to have to do an xy table. Now, x is squared, and it says y is equal to x squared. So I'm going to pick points for x and then square it to get y. So if I pick 0, then y would be 0 squared, which is just 0. If I pick 1, then y would be 1 squared, which is just 1. If I pick negative 1, it would be y equals negative 1 squared, which is also 1. Now in this case, because it's squared, I'm going to need a lot more points to be able to get the shape of this graph, because it's not going to be a line. It's not linear because of the squared term. So I'm going to pick something else. I'm going to pick 2. So y would be 2 squared, or 4. Negative 2. Negative 2 squared, which is also 4, and I could continue. It would be 3, 9, negative 3, 9, etc., etc. Plotting that, I have 0, 0, I have 1, 1, and negative 1, 1. Now, you think that you know what it's going to look like now, a V, but it's not, so let's keep going. 2, 1, 2, 3, 4, and negative 2, 1, 2, 3, 4. And what you begin to see is it is a curved graph called a parabola. And that's what all graphs look like if you graph a squared equation. So I needed the XY table for that one. Looking at the next page, we have intercepts. So intercepts are where the points on the graph crosses or touches the coordinate axis. So where it crosses or touches the x-axis and then the y-axis. So what we want to do is find the intercepts of the graph and the figure shown here. And you probably don't see a figure, but I'm going to show you what this figure looks like. It comes down, it goes like this, and then it goes up like this, and then it comes down like this, and then it goes around like this. And we want to name the x and y intercepts. So there's obviously more than one. So here I have an intercept. It's crossing the x-axis, so that is the point -3, 0. I also have where it crosses the x-axis right here, and I actually drew it incorrectly. It's supposed to be at 1.5, but that's okay. It's at the point 2, 0. You can see that. And then I have another one where it crosses right there, and that is at the point 5, 0. So those are the x-intercepts. Notice they all have a 0 in the y spot. Where it crosses the y-axis is here, which is the point 0, 3. And then we have it crosses here, which is the point 0, -1. And it crosses here, which is the point 0, -3. So notice that all the y-intercepts have zeros in the x spot, and all the x-intercepts have zeros in the y spot. And that's how we find the intercepts from an equation. To find the x-intercept, you let y equal 0. To find the y-intercept, you let x equal 0. So here we go. We have an equation, y equals x squared minus 4, and we want to find the intercepts. So I'm going to do a little xy table. To find the y-intercept, I'm going to let x be 0. To find the x-intercept, I'm going to let y be 0. So let's do the y-intercept first. I put a 0 in for x, and that gives me y equals -4. So that was an easy one. 0, -1, 2, 3, 4. This is so tiny, it's hard to see. To find the x-intercept, I plug the 0 into the y spot. So 0 equals x squared minus 4. I'm going to add a 4 to both sides, and I get x squared equals 4. To solve that, I take the square root, and I get x equals, now don't forget, when you take the square root, we want both the positive, and the negative. So I get x equals plus or minus 2. So I actually have two x-intercepts, 2, 0, and -2, 0. So I have the point 2, 0, and -2, 0, which is right here. And when I graph it, remember what I said on the other page, the graph of a squared equation is always going to be a parabola of some form. So that was pretty easy. All right, let's take a look at symmetry, and this is going to be new to a lot of you. First off, a graph is said to be symmetric with respect to the x-axis if for every point xy, let's take this point right here, xy, on the graph, you also have the point x -y on the graph. So they are symmetric across the x-axis. So you have the point xy and x -y. If they both are on the graph, then it is symmetric with respect to the x-axis. And we're going to explore this a little bit in more detail shortly. A graph is said to be symmetric with respect to the y-axis, so the y-axis, if for every point, let's do this one, xy on the graph, we have the point -xy on the graph. So if you have xy and that's on your graph, and then -xy is also on your graph, then it is symmetric to the y-axis. So notice something so far. Symmetry to the x-axis means you have a y and a -y with the same x. Symmetry to the y-axis means you have the same y's, but you have an x and a -x. That would give you symmetry to the y-axis. A graph is said to be symmetric with respect to the origin, right here, if for every point xy on the graph, so here is my xy, you also have the point negative x, negative y. So if I went over x and up y, here I go over x and down y. So I have to have negative x and negative y. And if that's true, then your graph has symmetry to the origin. Now let's look at how we use that and what that has to do. And at the top of the next page, you will see tests for symmetry. To test the graph of an equation for symmetry with respect to the x-axis, what you do is you replace y with negative y in the equation and you simplify. And I'm going to show you this in a minute. If an equivalent equation results, then the graph of the equation is symmetric with respect to the x-axis. With respect to the y-axis, if you want to check for symmetry, you replace x with negative x. And after you simplify, if you get an equivalent equation, then it is symmetric to the y-axis. To test for symmetry to the origin, you replace x with negative x and y with negative y. You do both of them and then you simplify. So let's take a look because it's much easier to see by doing it. So here I have an equation, y equals 4x squared over x squared plus 1, and we want to test it for symmetry. So first, to test for symmetry to the x, I'm going to put in a negative y. So I replace the y with the negative y. So what I get is negative y equals 4x squared over x squared plus 1. Now I have to simplify this because I don't want it to say negative y, I want it to say y. So I'm going to have to multiply both sides by negative 1. That will give me y equals negative 4x over negative 4x squared, excuse me, x squared plus 1. When you multiply by negative 1, you just put the negative either in the numerator or in everything in the denominator. And now you compare. Is this the same as the original? Well, no, it's not. So no, there is no symmetry to the x-axis. Let's check it to the y-axis. The y-axis, we put in negative x where the x is. So it starts with y equals 4, take out the x, put in a negative x, over, take out the x, put in a negative x. Now let's simplify. Negative x squared is just x squared. So did I get the same thing? Since this equation is identical to what we started with, then yes, my graph is symmetric to, if I graph this equation, to the y-axis. Now we're going to see if it's symmetric to the origin. You may already suspect the answer. That would mean I need to take out the x, put in negative x, and take out the y and put in negative y. So negative y equals 4 times negative x squared over negative x squared plus 1, or negative y equals 4x squared over x squared plus 1. But as we did here, we can't leave a negative y, so we're going to multiply by negative 1, and we already know what we're going to get. We're going to get y equals negative 4x squared over x squared plus 1. Is that the same as the original? Compare this to the original. It's not. So there is no symmetry to the origin. The only symmetry is to the y-axis. So here you will see 6 equations. You need to memorize these. You're responsible for knowing these basic equations. This is part of the library of functions. These are just key equations. So let's take a look. The first one is y equals x. It's a straight line. It should have arrows on it going through the origin. Here we have y equals c. That means a constant, a number. It's just a horizontal line. In this case, 1, 2, 3, 4. That would be y equals 4. That's an example of that one. Here we have y equals x squared. Again, arrows on the end. It's a parabola, and it goes through, it sits on the origin, y equals x squared. Here we have y equals x cubed, and in y equals x cubed, you have this shape, and it also goes through the origin. So the way to remember this one is 1 over x is a fraction, and so you have a numerator and a denominator. In other words, you have two parts, and this one has two parts. The one in quadrant 1, and then the part down here in quadrant 3. The last one is y equals square root of x, and it is just a very gentle curve that looks like that, starting at the origin. So make sure that you memorize and can match the equation with the graph.